Hello everyone. Let's talk about the acceleration of these two blocks M1 and M2 in this system. So here note that this is pulley 1, this is pulley 2. Let's say mass of this pulley is MP and this pulley can have any mass. Okay, no problem. We don't have to consider it because it is not movable pulley. And here there is a mass M1. Okay, we have to find out the accelerations of mass M1 and mass M2. Now here if you observe, this string has a tension T, suppose. Okay, now since this is the same string all over, we have the same tension all over, tension T. Okay, now for this pulley MP, there will be a tension T dash here downwards and the upward tension will be T dash. Okay, now let's look at the equations of motion. Okay, so here this mass m1. Okay, before going into the equations of motion, let's see what we can say about the relation of the accelerations of m2 and m1. Okay, now let me redraw this system over here. Okay, this system is somewhat like this. There is this pulley over here which is movable and there is this another pulley which is fixed. Okay, now see here, there is a block attached to this. Now if I assume this pulley goes down by a certain distance x, if this pulley goes down by a certain distance x, the length of the string that will go downwards is 2x, right? This one will go by x, this one will go by x. So this string will go up by 2x distance. So if the acceleration of the pulley is a downwards, then the acceleration of this block will be 2a upwards. So let's assume the acceleration of mass m2 is a up downwards, which because it has the same acceleration as the pulley, and mass m1 will be the acceleration 2a upwards. Now let's look at the free body diagram. Okay, let's say the free body diagram of m1 looks like this. We have the tension T upwards, downward force is m1g. Now the m1 block is going up, so this will be T minus m1g is equal to m1 times 2a, because 2a is the acceleration of the block m1. Now let's draw the free body diagram of block m2. So this is block m2. We have this tension upwards for m2, which is T dash, and the downward force is m2g. Okay, so m2g and T dash are opposite, so but it is going down with the acceleration a. So we have this equation, m2g minus T dash is equal to m2a. Now the acceleration is a. So here this is the second equation. Now let's look at the free body diagram of the pulley. This is the pulley over here. The pulley has two tensions upwards, that is 2T force, and downwards is T dash, and obviously the mass mpg. Okay, so here the tension T dash plus mpg minus 2T is equal to mpa. The pulley has the acceleration of a. So we have these three equations. Okay, we have these three equations, so we have to solve for acceleration. Okay, so let's look at the acceleration here. So if I add these two equations, second and third equations, we will get m2g plus mpg minus 2t is equal to mpa plus m2a. So this is what we get after adding these two equations. Now what we can do is multiply the first equation by 2. So multiplying first equation by 2, we will get 2t minus 2m1g is equal to 4m1a. Okay, now let's add these two equations, these two new equations. So if we add them, we will get m2g plus mpg minus 2m1g is equal to mpa plus m2a plus 4m1a. Okay, now let's solve for acceleration a. So what we will get, so let me write it in this box here. So acceleration a will be, if I take a common, we have mp plus m2 plus 4m1. This is equal to m2 plus m minus 2m1 times g. Now what will be the acceleration a? Acceleration a will be m2 plus mp minus 2m1 by into g divided by this whole term. So this is the acceleration.